Okay. So in the last meeting, we went over the part studios, so how to create your own parts and just how to navigate Onshape pretty much. So today we're gonna very quickly go over the feature scripts that I told you about last time, and we're gonna talk about assemblies. Actually, first, last time I said that I would show a sketch, a good example of a sketch for, let's see, there we go. So this is our shooter plate for our ultimate goal robot, and it loads. So it looks pretty simple at first, but there was more calculations than you would think to go on in there. So you can actually see that in the sketch. So I was telling about how you can use construction lines in your sketches, and that is basically what this is. So this is just our plate, and then you can see how this line right here is the shooter wheel, and this line right here is that guide. So we have exactly, I think it's 4 inches in between here, so that we know how much the ring would be compressed. And they should be used that exact same line right there to have, to use as a guide to create our guide, so we knew what we were doing. So that's just an example of how you would use those construction lines to help you to kind of visualize what you're about to make. And then I also said that there were drawings last time, and this is kind of an example of what that would look like. I don't know too much about drawings, so we're not going to really cover drawings, but this is what that would be. You can use them a lot to help when you're actually machining parts. So when we have someone else machine parts for us, we can create a drawing, and it helps them get an idea of kind of what they're making. So I just want to go over that real quick. So going over the feature scripts, we can go over into, let's go into day 2, and we could do this. So if you want to go into day 2, there's a small enough group that hopefully we can all work in the same document this time. So once again, let's create our own tabs, and that's going to be Part Studio, and then create Part Studio, and then rename it. And if anybody has any problems with that, let me know. But hopefully we should be. There's no plus sign again. If they're still having problems with this, I honestly have no idea why. Just create another document again, like we did last time, and see if that will work. And then I'm assuming everybody got the email about the feature scripts. So I am going to just go over how to use each of those really quickly. So the first one was chain path generator, but that one I tried to use the other day, and it's kind of an older one, and that one actually did not end up working for some reason. So I don't know why chain path generator does not work anymore. But there were some other ones that we could do. So what were the ones that I had? So spur gear, I know was one. Spur gear is pretty easy. You would just click on spur gear, and it will import one. And then all you have to do is go into here. So we could choose whatever number of teeth we want on the gear. So I can have that be 36. I can have it be 3, not 3. Have it be 15. You can change that number to however you want. And then this number is going to change based on how many teeth you have. I believe that is your pitch, so the number between your teeth. And then your circle diameter. So the actual diameter is going to be this circle, which is what's called your pitch diameter, which is pretty much the center of your teeth where your gears are going to mesh. So that's kind of like your desired size of your gear. So if you wanted your gear to be able to mesh with an already made gear, you would have to get the actual dimensions of that gear and use the same pitch diameter. And if you use the same pitch diameter, you'd have the same amount of teeth. And then you'd have the gear that would work with whatever one you bought off the shelf. And all of that information is going to be in the documentation of the part that you bought. And then that is pretty thin. The root fillet is going to be the angle of this, I believe. Or that's the angle, this one. But this one is pretty easy especially for prototypes, making smaller gears. And then you just press this enter button up here to confirm your gear. And this one is a giant one. I believe the other ones, I need a quick circle. You need a circle or a cylinder for the next couple. So I'm just gonna make a cylinder really quick. The next one was thread generator. You need some sort of cylinder for this one, and then you're gonna select it, the cylinder, and it will automatically put some threads in for you. You can adjust the pitch of the threads. Just like that. And that's pretty much all we use on that one. And then I believe you're usually going to be using standard. That's another thing that you have to check with your whatever screw or nut you're trying to match. And then this one is kind of like if you wanted a shoulder belt, you'd be able to adjust how far it is threaded down. So that probably wouldn't be used for like a practical sense, but it would be used more for your CAD if you can't find like the CAD of what screw size you want. And then spacer, you have to have a circle. So rather that's an extruded part or just a sketch of a circle, it will take that diameter and create a spacer for you. So it will have a hole in the middle, and you can't adjust the hole, you adjust the thickness of this right here. So I could change that. And it will adjust the thickness. Oh, that is the hole. That is the hole. Yes. So you can adjust the thickness of the hole inside of there. And it will automatically give you a spacer. And then this one is your length of the spacer. What was the other ones I had? No, I have it written down. Okay, so then the other one was chain path generator, but chain path generator is not working, like I said. What you can do is use chain path builder. And no, not chain path. I have too many of these. Chain generator. And you would put in your center to center distance. Now your center to center distance is not going to be 12. You'd have to use what's called the chain calculator. The one we use is called the Recalc. It's RECALC. and you basically just put in the size of your sprocket and the size chain you want, and it will calculate it for you. So you just put in that center distance here, and then the size sprocket you're using, so the number of teeth on that sprocket, and it will automatically adjust the size for that. And then the pitch of your chain, normal FTC chain, standard size FTC chain is 0.25, and then bicycle chain is 0.35. And then you also have this simplified version, which is flat, or you can change that to realistic, and it will change to actual looking like chain. And once again, this is just pretty much just cosmetic for you to use in, what's it called, in your assemblies, just to show that there would be chain whenever you are using chain. And then this one, I don't know if most people are going to be using this one, but it is pretty much just a really easy way to repocketing. So you might see some people that CNC their own parts and they have like cool patterns inside of it. You can use something like this for that. And you can see that it just creates its own type of pattern. You could change the depth on it if you don't want it to go all the way through. And then the holes, you could take out the holes completely or add them in, and you can make the pattern bigger or smaller depending on how big of a plate you have. So that's the main feature scripts that we use. It just makes life a whole lot easier. So instead of having to draw a bunch of triangles, it just generates it. Or instead of having to make a bunch of spacers, you could use the same circle to make other spacers. So it just makes life a whole lot simpler. So that is pretty much all I had for feature scripts right there. And now we can move on to our assemblies. But before we do that, we do need some parts, since everybody is working in different documents. And my Onshape is going to not like me and load forever. So we are going to make this real quick just so that we can show better what we are about to do. So if you want to follow along so we can all have the same parts once we get into the assembly, it is a pretty simple sketch. So we are just going to have a rectangle, a center rectangle from the center and go out. And each side is going to be 2.5 inches. And then just make all of the sides equal. So equal and then both sides. And you'll have a square. And then we're going to take a line and we're going to have that be a construction line and have that be a 1-inch line, or it's 1-inch line. And then put the midpoint. So grab midpoint, select the line, and put the midpoint at the origin. And then we are going to take some circles and make them 1/2 inch. And we can set those equal as well. And then last thing is just drawing a line straight down the center. So everybody can have that done real quick. And then we are going to extrude, so that is Shift E, with this button up here to extrude. This rectangle and this circle are going to be an inch and a half. And then it's going to automatically hide your sketch, so we need to come and press the eyeball so that it shows up again. And then have these two and extrude that 1 inch and make sure that those are both in new parts and not on add. So new parts so that they are their own thing. Actually, you don't need this circle. I take it back. Just this rectangle part. New part, 1 inch. And then really quickly so that we can see something later, we're going to create a sketch on top of this circle here. So click that circle and then press sketch. And then we're just going to draw a rectangle right there. And you can dimension it if you want or not. It doesn't really matter. And then we're going to extrude that. Except we're going to extrude it down 1/8 of an inch. And that is going to add to this circle. If this part is red for you, if it looks like this, if it's blue, or if this part is red, you just have to hit that merge scope button and make it merge with that part. And that is it. Does everybody have that? Is that sketch for you? Remember, if you need to get this dimension tool, that is right up here. And you can just click that and then click the line and then type a 1. And that will give you that distance. And then to get that line in the center, we did, oh, line Q, dimension, 1 inch, and then we went to the constraints and we got the midpoint constraint and clicked the line in the origin. Right now, I'm not too worried about getting it perfect. We really just need the parts so we can put them together, pretty much. And then that circle and this half was 1.5. And then this one is 1. So remember, you have to select them separately when you go to extrude. And then do another extrude and select this one. That way they're at different heights. So Liam, I think your problem is your line right here needs to be a solid line. So you should be able to go in your sketch and click on that solid line and click construction, and it should go away, and that should solve your problem. Perfect. Now last thing is the little doodad on top here. And that's undimensioned. It's just a rectangle on there. And then extrude it downwards. If you need to change if it goes up automatically, you just need to press this little arrow to make it go down. So all you have to do for that is do a sketch and then select that top part as your plane. And then you can sketch on top of that. So you can select multiple things in one extrude. So you can see I'm able to select this side and this side in the same one. Perfect. All right, so now that we have that, we are going to talk about assemblies. So an assembly is a different tab. So you have to insert another tab, but this time press create an assembly. And then you can go ahead and rename that assembly. And you'll always be able to tell that the little square doodad is the assembly and these little rectangles are the part studios. So in your assembly, what an assembly is basically is when you take your parts and you put them together, or you take other parts and put them together. And you do that using things called make connectors that we will get into in a minute. But to put things together, we have to actually get the parts. So to do that, from your assembly, you press insert up here, and then you have 3 options. So your current document, you're gonna have access to every part studio in here and every assembly in here. And once you have an assembly, you'll be able to see that. But we have access to all the part studios. So if you click on one of the part studios, it will just import all the parts at once. If you click this little drop down, you're able to import one at a time. And you have to actually click to put it down. If you press the X, everything is going to go away. So you have to actually click the check mark for it to stick. Do you have the FTC part library? So you should be able to go to other documents and see the FTC robotics part users. Do y'all have that? It should be a team. Once again, from here, that is other documents. And then you should have this. Put in the chat if you do have it or if you don't. They may have not given access yet, which is really annoying that they don't do that. There's nothing in shared. Well, it should not be in shared with me. It should be a team. So there should be other documents, and it should be right down here. With the little people on the left. You should have the intro to Onshape class, and then there should be this one. Okay, then they haven't added you. They can take some time sometimes. They have to actually add you to the team, so sometimes they don't do it right away. So I will hopefully they do that. But when you do get access to the revised part users, and hopefully by next week you will, you would go to other documents and press that, and then all of this is set up exactly like the websites that they are. So all of your robotics parts you most likely get from one of these places, Rev, GoBuilda, and eMark Servo City. And they're all set up exactly like the website. So if you see, when we click on GoBuilda, they have motion, structure, electronics, all of that, all the same. So if I click on motion, I have all of these exact same options. So if you ever get stuck looking for a part, you can actually find it on the website, and that will show you how to do it on here. So if I wanted to find a sprocket, let's say I wanted this hub mount sprocket. Yeah, that's a bad one. Hubs are a good one. Let's say I wanted a hub. So this will actually tell you, you can actually see up here, it says motion, hubs, shot by style, and let's say I want this one, I'll press imperial. And you see that it is the exact same way. Gavilda, motion, hubs, and then they have the sonic hubs and all the different ones on here. um, it doesn't matter if it has the right dimensions or not. It is, we basically just need the shapes to be able to show about the shape. So you would go through here and then you'd be able to click on the parts. You want the assembly if it's an assembly. If not, you'll be able to just click on the parts and bring it in just like that. You can also do that with any other documents that you have. So let's say you're making a robot document and you're trying to make a full robot assembly, and you build your drivetrain in one document and your lift in a different document and a claw in a different document. You'd be able to actually go into those documents the same way and grab those assemblies and parts just like that. And you can also search public on here as well. And then they also have some standard content is over here. So that is things like screws and washers and nuts and just random things like that. So they have washers, they have different types of washers, and then they have different size washers. And all you're going to do is press insert once you get all the right stuff that you want. You can change it to screws and get some standard, you know, some normal screws, and you could change the whatever head you want and whatever size you want, and it will give you a screw of that size. Obviously it's not threaded just because it makes it easier for Onshape to render. But that is some standard content that you can get that Onshape just has for you to make yourself pretty easily there. And then you can also get stuff off of, so let's say that you don't have the parts library yet, but you still can get, you can still get the parts from here, from the actual website. So for example, GoBuilda and Actibotics, and well, actually pretty much all the vendors that we use are the same. If you click on their part, if you scroll down, you will see a step file. And if you click on it, you will download it, and you can actually go over here and import, and you will be able to import the part, and it will show up in its own tab and do its own thing, and you will be able to insert that from your current document. So that is how you can actually get the same parts without being on the part library. But for now, we're just going to use these parts that we made because they were made for this. So you can see right now everything comes apart because nothing is mated together. So what we use in assemblies to put things together is called mates and mate connectors. So basically your mates and mate connectors are the virtual screws or glue that hold your parts together. So a mate connector is what is actually on here. So that is like the point that you are going to put to another point. That's called a mate connector. This little circle that is going up on these white dots, that is what's called a mate connector. A mate is the actual one that you're going to put. So you use a mate, you grab a mate connector and click another mate connector, and it will glue them together. So there are different types of mates, but there's only one mate connector, but there are different types of mates. So the first one is a fastened mate, and that is pretty much just like a glue. So you can click this one up here. This is fastened, and you will select one of these. You select a mate connector from one part, and select a different mate connector from another part, and it will just put those two together. And if you press, they'll have this little menu pop up. If you press this button right here, it will rotate the part. If you press this one, it's going to flip the axis of it, which looks really weird. And then you can actually press, if you press this check mark, it will just bring you to having another mate connector. It will keep the same mate connector menu open, and you can rock and roll all through like this. But if you click the mate connector check mark up here, it's going to take you out of that menu. And I have messed that up. Now. So sometimes it can be hard to select your mate connector. So let's say I'm doing a fastened mate and I want that center one down there. It's kind of hard to select. So if you actually select in here where all three of these little white circles pop up, you can hold the shift button down, and no matter where you move your mouse, those three are going to pop up, which is very helpful too. So most of the time when we're mating things together, we're going to mate the faces. So like this face to one of these faces. It doesn't really work when you do like a corner or a line or something like that. Doesn't, more often than not, doesn't work like that. It's easier just to mate a face to a face. And you can do all these other ones instead of just the center one. You can select the side one and go to the side one, and it will do the same thing, but now it's not centered. So that is your facet mate. The next one is a revolute mate, which you can probably tell what it does already. So the revolute mate is for, you're mostly going to use it on circles and cylinders. So if we take the bottom of this revolute of this cylinder or the middle, the bottom is usually easiest because then you could just select this ring down here and it will select like that. Oh wait, no, that's the wrong one. This one. And if you ever select the wrong thing, instead of just deleting the part over here, you can actually just delete it using these arrows. So you can see which one you selected and do it that way. So with this one, it allows you to actually rotate. So one thing that I will mention about making assemblies, you always want one part to be fixed in place so it can't move. So right now, everything here can move. Even though they're stuck together, the whole thing can move. So if you right click on one of the parts, you get all of these options. The most important one right here is fix. You want one part in all of your, every time you make an assembly, you want one part to be fixed. That way the whole thing doesn't move. Then you try to move other things. So now that is fixed, I'm actually able to rotate this part right here, since I have a revolute mate on it. So let's say you were making something like a turret or a shooter, not necessarily shoot, but a turret or an intake or something that you need to spin in CAD to see what it's going to do, you would use that revolute mate. One thing to note about revolute mates is they are notorious for making Onshape run very slow. The more revolute mates you have, the slower it is going to run. So you want as little revolute mates as possible when you are CADing, because especially in Onshape, because that it just makes it so annoying when you have a million of them. So that is the revolute mate. So to delete parts or fastens, you just click on it and you press delete, or you right click and press delete. Sometimes it only likes to right click one. So you see I fixed it so this one can't move. So the next one is a slider mate. So just like you would think, that one slides and doesn't allow you to do anything else. I believe this one only lets you slide vertically up and down. So this is what you would use in like the case of a linear slide or something like that. So usually when you're doing linear slides, I'm gonna make it like this because that's how you would do it. You would go to the bottom of the part and select the edge of both of those. And that's how you would do a linear slide. And now you can see that it could go straight up and down. Like that. So once again, that's how you would do something like a linear slide. Would be a slider mate. And delete that one. And the next one is a planar mate. So that basically you're gonna select a mate connector that is on the plane that you want it to be on, and then you're gonna select the face that you want to be on that plane, and then you are gonna be able to move this all around, but that face will stay on that plane, or it should, but it's not working very well. Sometimes I just don't understand this one. Also, maybe it's because this one is fixed. Yeah. So now that that one's fixed, you can see it moves just in a pretty weird way. You can see it is staying on that plane right there. Um, so when we did that one, you see that the first point that we select, I'm gonna select this one now. That's gonna be the side that can move around freely. And then the second point is gonna be the stationary one. So now if I were to fix this one, now that I click the blue one, the dark blue one first, it's still gonna be weird. And it's broken. Oh, oh no, it's still on the plane. It's still on the plane. It was broken. So yeah. And then cylindrical mate is an interesting one. I'm gonna fix this one again so that it doesn't move. A cylindrical mate is basically a slider mate and a revolute mate in one. So I can select that now. And it will actually be able to slide in and out and rotate as well. So sometimes that would be used for like a pin or something like that, of that nature. And then the last one I have on here is a parallel mate. So this would be something that you would use if you are making like a linear slides and you have two of them and you want them to be the same going up and down. You want them to go up and down together. You would use a parallel mate. So you would do this one, the top and the top of that. And basically I can move them, well, not that one. It's gonna be broken. But these are gonna move together, or they should. But they're not. Why? Parallel one is, it's just like planar. It gives me trouble sometimes. So they're basically just gonna stay parallel with each other. If you have something like a pivot. You can see that they're gonna move together and stay parallel when I move them. The planar mate is the one that's gonna keep it like a linear slide. That's what the planar mate is. This one is for like a pivot, if you were doing a pivot. Okay, so that is all the main connectors that we use. Mostly there are the pen slot one and the ball mate and tangent, but we've really never used those very much. The ones that I showed you are most commonly used. There are a few other tools in here though that I will go over. And that is going to be, where the heck did the gray, oh, I deleted it. Need the little pen. So I am just going to make this, actually no, not. So sometimes when you import something, let's say I imported a servo from GoBuilder. The servo will come in a bunch of pieces. Actually, let me do that. Let me stop screen sharing, and I'm going to download a servo. You don't have to do this. I'm just, for example. Okay. So to import something like that, I went over here and I downloaded it, and you just press import and select the file you want. And then it's going to ask you this. It's going to ask you if you want it to go into the document. It's like an assembly and a part studio or a part studio. I'm just going to do a part studio for this demonstration. And then it's going to ask you all these questions. Typically, you're not going to need to change anything. Sometimes other softwares will have the y-axis pointing up, whereas in Onshape we have the z-axis pointing up. So it'll ask you if you want to orient it differently. But for other GoBuilder models, typically it's z-axis up, so we don't have to mess with that. And then it is going to upload, and you're going to have a CAD imports file show up. It's going to have this weird picture, and then this will show up. And it is multiple parts right now. See, it is 2 parts. Usually it is a million parts. It is like every screw and every tiny gear that is in the servo. And it makes it a whole lot difficult. So for this one, it's only 2 parts, so it's not that difficult. But imagine it is a bunch of parts, and you move that, and then everything is in there. Which is pretty annoying. So I'm just going to delete those real quick. If you have something like that where it's a bunch of parts and you don't feel like, and it imports in a part studio like this where it looks put together, and you don't feel like taking it apart and mating it all together, the simple fix would be to just import it as the part studio, so it imports just like it is there. You can select both of the parts and go up to this little group feature right here, and it will group it together. Group all the parts together so that they can't move. Instead of having to mate a million parts together, even though this one only imported as 2 parts, it would be pretty easy to just mate that one part on. But This is an example. Another one that we use really often, most often with things like screws. Let's say you have a plate with a bunch of screws in it, a bunch of holes that you need screws in. Instead of importing 20 different screws and mating 20 different screws individually, you can actually do it with one screw and one mate. So to do that, we would just do a mate. The shortcut for a mate is M on your keyboard, or you can just press this over here, and you can actually change it on here. But I'm just gonna do a fasten mate for this. And you select what you want, where you want it to be. You see I made it in there. And then now instead of duplicating this and creating another mate, you can actually use this replicate tool. It's going to ask you to select an instance, which is your part, and then it's automatically, 90% of the time, it will automatically know which mate it is that you are copying. So you have all these options to match faces and parts, features, or individual edges or faces. Typically, individual faces is going to be easiest because that's going to be like, well, not faces. Yeah, this one. Match faces and features. So you can actually select like an edge. So you would actually be able to go in and select the hold that you want. Nope, not that. Individual faces. Why are you doing it? Oh, it's selected multiple parts. That's why. And make sure there's only one part selected in there. Okay. So my problem is I'm not selecting this. So make sure that this is blue when you are touching it. Whatever is blue is what you are on. And what's red needs to be filled in. Why is this not working? Replicate that part. This one. That fits. Okay, it does not want to work with this one. With this part for some reason. Put something else in here. It's probably not the same size or something like that. But let's just say I have a bracket in here. It's, I have a bracket. And then I'm going to get a screw. And it's going to be a 632 screw. Did not insert it. Insert that one. And then you can see that that one comes with the mate connector on it. So sometimes it comes in like that, and to fix that, you would just press this flip axis button, and it'll fix that for you. Now, to replicate instances, select the screw, and then faces to match, and it will automatically take whatever hole is the same size as the one that you had, and it will put a screw in it. You could do individual edges if you wanted certain screws, and click those individual places. Now you see that one's not the same size, so it's not going to work. And you can click the individual edges for those. So that is how you could do the replicate tool if you had something like a plate that you wanted to put a bunch of screws in. And that would work. And then the last one, they have this gear relations tool, which can be pretty hard to work with sometimes. So I'm not really going to go over it, but you'd be able to make things move. But typically you would just use a Revolute Mate for that because it is a lot easier to do it that way most of the time. So just a few more things to go over with assemblies before we go. If you right click on a part you get all of these options. So the first one is going to be hide, and you can hide all of your instances. And if you do that, if you right click, you can press show all instances. If you hide all of your instances and then press show all, it is going to show all of your mate connectors as well and your mates. So it's going to show the connectors, and then it's also going to show like that is a fastened or a group or whatever it is. And when you have a really big model, like a full robot document, you have a bunch of those, and it will be annoying to get rid of them all. To get rid of those mates, you have to actually right click on the mate, and then you'll be able to hide other mates or hide all mates. Same thing with mate connectors. Hide all mate connectors. To hide parts, it's going to be instances. You can hide all other instances, or you can hide all instances. You can also go over here and click the eyeballs, and that will hide parts, show parts, and same thing with mates. And you'll see the mates have these little drop downs. That's going to be the mate connectors that they are connected to. And that's how you'll be able to see some of those as well. So now you haven't, now that we have some type of assembly, if I go into someone else's assembly, or I could just import someone else's assembly. If you insert, you can actually go to and insert other people's assemblies or other assemblies that you have as well, and they will function just like the assembly that they were in. So again, when you're assembling something, it does not necessarily mean that you are making it one part. So I'm gluing these together, but they're not one part. They're still separate parts. It's just like screwing pieces together, I guess would be the best way to say it. So that is pretty much all I have for class today. This class was definitely not as long as last time. But there is much less to cover this time with assemblies. Hopefully next time you'll be added to the parts library. I'm not 100% sure. Liam, I thought they would be added by now, but they were not. So I'm probably gonna email them and ask them if they could get a move on with that. But if not, I'll probably just import some parts for you. In the next class, I think we're gonna go over some more stuff with measuring and weight and changing things like that. And then I will have something for y'all to actually assemble. So before I go, are there any other questions? All right, well, thank you for coming to class. I will see you again on Wednesday. If you need any help with anything over the week, just email us. All right, bye guys.